Hey guys, Miss Binkley here again, and this time we are going to take some notes on how to simplify radical expressions that are not perfect squares so that they're a little bit easier to work with, plus some questions will have them as answers. So let's take an example of a perfect square. So this is just review right here. But if we have the square root of 4, that's 2, because 2 times 2 is 4. But let's look at something we can't simplify or can't reduce, and that's the square root of 2, because that's not going to be a perfect square. It's going to be, I believe, 1.4 something something something, right? So we would rather you just keep it as the square root of 2, because that's going to be our exact answer. Okay? But if we have something that is not an exact answer, like if we have the square root of 8, right? That is the same. There's no exact square root of 8, but we could say 8 is the same as 4 times 2, right? So the square root of 4 times 2. And that's equal to the square root of 4 actually has a square root, right? That's 2. So we can cancel that out, bring the 2 out. The square root of 4 is 2, so we bring it on the outside. So then we just have 2 times the square root of 2. Okay? So instead of writing the square root of 8, reducing and simplifying it would make it the square root of, or 2 times the square root of 2. And if you type in fact, I want you to do that right now. I want you to pause. I want you to type in the square root of 8 into the calculator and write down what you get. Then I want you to type in 2 times the square root of 2, hit enter, and you should get the exact same number. So please try that and let me know. I mean, that should give you the exact same answer. Let me know if you're not getting the exact answer, because what that means is you're probably typing it into the computer wrong. So what did we do there? What we did was we needed to figure out how we could break 8 down into a number that had an exact square. All right? And there's a couple of ways to do that. I knew that 4 times 2 was 8, so I found a factor where one of them was an exact square. So that's what I want you to do for step 1. Find a factor, and you write this down, you just don't write squiggly lines. Find a factor where one of the factors is an exact square. Okay, and we may have to do that a couple times. Let's try another one, like another easy one. The square root of 24. Okay? Again, I know that 4 is a perfect square. So I know that that's the same as the square root of 4 times 6. Now I could have said the square root of 8 times 3, but neither 8 or 3 has a perfect square root, right? So I picked 4 times 6 because 4, the square root of 4 is 2. So then I can pull that out. The square root of 4 is 2. Then I still have the square root of 6, but I know my factors for the square root, my factors for 6, none of them are going to give me a perfect square. So that's going to be my final answer. Now, step 2 is, how do you go about doing this, right? You could just find factor pairs. That's what I do. So I start with, does 4 go into it? And that's the first perfect square. And then does 9 go into it? That's the second perfect square, right? So you could do it that way. You could write down step 2 as create a factor rainbow, remember? So we can do it this way, and then I'll show you the way that Mr. Ryder does it. We do it a couple different ways. I would say, like, say we have the square root of 42. Would that be a good one? Or let's pick an easier one just off the top of my head. How about the square root of 12? Okay, so if we're trying to do the square root of 12, And we want to find some factor pairs. We use a factor rainbow, right? We have 1 times 12. All right, and those multiply together to give me 12. Then we have 2 times 6. And we have 4 times 3. Okay? So of these factor pairs, are there any that give us a perfect square? And you're right, the only one here is 4. So that's going to be the square root of 4 times 3, which is going to give us 2 root 3. Okay? So that's one way. So step 2, make a factor rainbow. And pick a pair that has a perfect square root. If they both have perfect square roots, then you can use both of them. That's fine too. Step 3, or actually let's do step 2A, and let's call step 2A Mr. Ryder's way of doing things. Okay? And his way is he finds prime factor. So I did factor rainbow. Mr. Ryder finds prime factor. So let's do it again with 12. And he does, okay, we make a factor tree. So 2 times 6. And then 6, we can do 2 times 3. Now, these are our prime factors, right? And if we have more than one of the same number, 2 times 2 is 4. So we know that 4 has a perfect square because it's 2 times 2, right? So he did the same thing, but he used a factor tree. So you pick which way is easiest for you. All right, and that's step 2. Step 3 is you may have to do it more than once. Let's see. Oh, my step 3 is not coming out very well. Step 3. You may have to do it again. So let me try to figure out if there's a number we can use, a good number we can use to represent what I'm talking about here. Let's try 100. Let's see. Actually, I'm going to pause. You don't have to pause. I'll be right back. I'm going to find a good number to use. Hold on. Okay, you guys, I'm back. So let's do a little bit of a harder one, and that is the square root of 288. Okay, so let's see. The way I'm going to do it is I'm just going to use the first perfect square I know, which is 4. So can 4 go into 288? And it can. 4 times 72 is 288. So that's the square root of 4 times 72. Okay. But I think we can break down 72 into smaller parts also. So what, can 4 go into 72 again, or even just 2? 2 can go into 72, which might be an easy way to break it down. But again, let's think about 4. So let's see if 4 can go into 72. So 4 divided by 72. Oh, I meant the other way around. Sorry, you guys. 72 divided by 4 is 18. So we can change that again to the square root of 4 times 4 times 18. Now, is there a perfect square that can go into 18? 4 can't go into 18. What's the next perfect square? 9. 9 can go into 18. So what is that going to look like? It's going to look like the square root of 4 times 4 times 9. Okay, so I know this is weird, but I just jumped forward because I ran out of room and paused. So I know this looks different, but what I did is I just broke it up. You can do this if you're multiplying numbers underneath a radical. You can break them out. So what I had written down before is the same as the square root of 4 times the square root of 4 times 9 times the square root of 9, times 2. Now it's really easy. We have 2 times, right? 2 times 3 times, there's no square root of 2, so we leave that as the square root of 2. So 2 times 2 is 4, times 3 is 12. So our final simplified answer here is going to be 12 square root of 2, which you can check in your calculator and make sure you get the same answer as you did the square root of, what was it, 288 that we were looking at. So double check that. So there's a couple of different ways to do it. I would like you to make sure your steps are written down the way that you would like to do it. You can have me come over and help you out or rewatch the video. And why don't you go ahead and try doing the square root of 72 for me. So try doing the answer for the square root of 72 and having me come over and check it. Thanks.